Redox reactions. The reactions in which electrons are transferred from one reactant to the other are called oxidation or reduction reactions. We also call them redox reactions. The reaction between hydrogen and oxygen is a combustion reaction, and hydrogen gas reacts with oxygen to form gaseous water. This is an example of an oxidation reaction in which combustion takes place. The reaction between sodium and chlorine is an oxidation reduction reaction without the presence of oxygen. Here, electrons are transferred from sodium to chlorine to form sodium chloride. In a redox reaction, we convert a free element into an ion by gaining or losing electrons. Atoms that lose electrons are being oxidized, while atoms that gain electrons are being reduced. As seen earlier, sodium and chlorine will react to form sodium chloride. The sodium atom loses an electron to form a positive charge, while the chlorine atom gains an electron to form the chloride ion. The transfer of that electron from sodium atom to form a sodium cation is called oxidation. The acceptance of that electron is called reduction. For reactions that are not a metal plus nonmetal or do not involve oxygen, we need a method for determining how electrons are transferred. Chemists assign a number to each element in a reaction called an oxidation state. The oxidation state allows them to determine the electron flow in the reaction. Rules for assigning oxidation state. Free elements have an oxidation state of 0. The sodium atom equals 0. Chlorine gas equals 0. Monoatomic ions have an oxidation state that is equal to their charge. Therefore, sodium has a +1 and chlorine has a -1 in the NaCl compound. The sum of oxidation states of all the atoms in a compound is 0. So Na equals +1, Cl -1 in NaCl. +1 plus -1 equals 0. The sum of the oxidation states of all the atoms in a polyatomic ions equals to the charge on the ion. For example, in nitrate, which is NO3-, nitrogen has a +5 charge. Each oxygen has a -2. Since there are 3 oxygens, it is 3 multiplied by -2, which is -6, until the overall charge is equal to the charge on the ion of -1. Group 1 metals have an oxidation state of +1 in all compounds. For example, Na equals to +1 in NaCl. Also, group 2 metals have an oxidation state of +2 in all of their compounds. In their compounds, nonmetals have oxidation states according to this table. Fluorine has an oxidation state of -1, for example, in magnesium fluoride. Hydrogen has an oxidation state of +1. Oxygen has an oxidation state of -2. All group 7 compounds have oxidation states of -1. All group 6 compounds have oxidation states of -2. And group 5 compounds has an oxidation state of -3. During a redox reaction, the reactant that reduces an element in another reactant is called the reducing agent. The reactant that oxidizes an element in another reactant is called the oxidizing agent. What this means is the reducing agent always contains the element that is being oxidized. The oxidizing agent contains the element that is reduced.